All right, so this is lesson 5.6, part 2. So problem 3, using theorem 511, which choice shows the sides of triangle LMN in order from shortest to longest? Well, again, the longest sides are opposite the largest angles. So the longest side would be opposite that angle, and we want to go from shortest to longest. So the shortest side would be opposite that angle, and the one in the middle would be opposite that angle. So in order, the shortest one is going to be the one opposite 51, which is LM. So that gives us either A or C. The middle one is the one opposite the 64, which is this side, MN. So the second angle should be MN, and that's that one. All right, reasoning. In the figure at right, measure of angle S is equal to 24, measure of angle is 130. Which side of triangle SOX is the shortest side? Explain your reasoning. All right, so if we label this is the 24 right here. This is the 130, and by the third angle theorem, you know that we can find the missing angle, or by the triangle angle sum theorem. Sorry about that. So the measure of angle S plus measure of angle O plus the measure of angle X is equal to 180. So the measure of angle X is equal to 180 minus the other two angles. So we need to do 180 minus 24 minus 130. And that's equal to 26. So we now have that. Angle X is 26. So 130, that's angle O. 26 is angle X. 24 is angle S. And so the side opposite O is the side that doesn't have the letter O in it, so that would be side SX. And OS would be opposite X, and OX would be opposite X. So which side is the shortest side? That would be the side that is opposite the shortest, the smallest angle, so that would be right here. The shortest side is OX because it is opposite the smallest angle, angle S. All right, for three segments to form a triangle, their lengths must be related in a certain way. Notice that only one of the sets of segments below can form a triangle. The sum of the smallest two lengths must be greater than the greatest length. Otherwise, the other two sides wouldn't reach each other to form a triangle, basically is what we're saying here. So this is called the triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. So complete each of these inequalities. Side xy plus side yz must be greater than the other side, the one left over, which is xc. The length of yc plus the length of zx must be greater than the third side, which is xy. The length of zx plus the length of xy has to be greater than the third side, which is yz. So we can use that to figure out whether or not you can create a triangle with those side lengths. Can a triangle have sides with a given length? Explain. Well, if it can, we have three things that have to happen. 6 plus 8. We have to see if that's greater than the third side, which is 13, and that answer is yes, so that's okay. Also, 6 plus 13 must be greater than 8, and 8 plus 13 must be greater than 6. And all of these are true. So yes, by the triangle inequality theorem, write this by triangle inequality theorem, you could have a triangle with length 6, 8, and 13. What about the second set there? 3, 9, and 12. Well, again, we got to check three things. We've got to make sure 3 plus 9 is greater than 12. 9 plus 12 is greater than 3, and also that 3 plus 12 is greater than 9. And you can see that two of these are true. So that's true, that's true, but one of these is false. And in order to make a triangle, you would have to have all three of these be true, so no. 3, 9, and 12 would not work. That one did work. And it's because 3 plus 9 is not greater than 12. Alright, so you can try it here. 8 would have to be, 8 is less than 9. 15 is greater than 2. 11 is greater than 6. So one of the sums is not greater than the length of the third side. So it is not possible for a triangle to have side lengths 2, 6, and 9. All right, finding possible side lengths. If two sides of a triangle are 7 or 9, what is the range of possible lengths for the third side? Again, we're going to use the triangle inequality theorem. Let's let x be our missing length. So we have side lengths x, 7, and 9. So we know by the triangle inequality theorem that x plus 7 must be greater than 9. We also know that x plus 9 must be greater than 7. And we know that 7 plus 9 must be greater than x. Now, solving each of these inequalities, if we subtract 7 from both sides here, we get x is greater than 2. If we subtract 9 from both sides here, we get x is greater than negative 2. And if we simplify this, we get 16 and it's greater than x. Now, one of these doesn't work at all because you can't have negative side lengths, so we're just going to ignore that one. And we're going to say that x has to be greater than 2, and also x has to be less than 16. So we can write these as a compound inequality. 2 is the smallest possible value. Actually, it has to be more than 2. 2 wouldn't work. So 2 is less than x is less than 16. So the range of possible values are between 2 and 16, not including 2 or 16. All right, go ahead and you try that here. All right, a friend tells you that she drew a triangle with a perimeter of 16 and one side of length 8. How do you know she made an error in her drawing? If one side is 8 and the perimeter is 16, then the sum of the lengths of the two remaining sides must be 16 minus 8, which is 8. Underline the correct words. By the triangle inequality theorem, the sum of the length of the two sides of a triangle must be greater than the length of the third side. By the triangle inequality theorem, the sum of the lengths of the two unknown sides must be greater than the length of 8, the known side. But 8 is not greater than 8, so therefore, you must be in error. All right, I'll see you tomorrow.